So we are good to go. Good evening, everybody, and thank you very much for joining this Center for International Relations in Sustainable Development Youth Expert panel series. This is the first discussion in what will hopefully be a very long series, and our first seminar is going to deal with the issues related to healthcare and geopolitics, and it is themed the world in 2021 and beyond. Now, I believe that most of the people present here know, but just for the record, Center for International Relations and Sustainable Development is a Belgrade-based, very much globally minded think tank. In the past 7 years, we have grown into the leading think tank dealing with foreign policy and sustainable development in Southeast Europe. We are proud publishers of Horizons, a quarterly journal of international relations and sustainable development that has become the only publication from Southeast Europe that is available on JSTOR. CIRST has been hosting in vivo or virtually or by means of being an author in the Horizons magazine, some exceptionally interesting crowd ranging from Nobel Prize winners to the head of the IMF to the head of the Asia Infrastructure Investment Bank to the intellectual giants of the like of Jeffrey Sachs and Neil Ferguson, Nouriel Roubini, people of that stature, ranging from various fields, but also various political views. We do also have, and it's very important that I mention it here, a growing internship program. And as a matter of fact, this internship program so far has had brilliant students from around the world, from Harvard to Georgetown to Sciences Po to Shanghai, but also leading Serbian and Balkan universities. And as a matter of fact, this particular series has been thought of and engineered, and now it's being carried out by our present interns, an exceptionally outstanding group of young people who I use this opportunity to thank for making this possible. As far as the participants in today's conversation are concerned, we received literally hundreds of applications, but we decided to give the priority this time around to students from our part of the world. So we have students from Serbia, from Bosnia, Croatia, Montenegro. There were some outstanding applicants from elsewhere, so we ended up having a very versatile mix of US students and Brazilian students and students from Ethiopia and so on and so forth. But what is in common is that they really stand out by means of their biography and mission statement that they provided as to why did they want to join our conversation this evening. Upon the end of this series, this particular seminar, and there are two discussions. One is today with you, Samir, on healthcare, and the other is tomorrow on geopolitics. Upon the completion of both, students are going to receive certificates from the Center of International Relations and Sustainable Development. And they are, at the end of this conversation, they'll have a chance to ask you direct questions for about 30 minutes if we don't bore them to death in the first hour of our conversation. Now, I want to introduce Samir to everybody. I'm sure most of you read your biography, especially the professionals. I should mention that there are a couple of professionals who are not exactly students at this moment, but who have sent us emails saying, "Oh, we got to meet Dr. Khleif," and therefore we have such sort with us as well. But for those of you who haven't had a chance to read it, Samir Khleif is, first of all, an exceptionally good friend of mine. We met years ago in one of those special closed secret meetings that we're not supposed to talk about. But I fondly remember our first encounter where we ended up talking for hours about the problem of Palestine and the Middle East in general. Nothing to do with Samir's field of expertise, but since we really stayed in touch and not just stayed in touch, but become very close friends, ended up meeting in various parts of the world. And his biography is really astounding. He's a world-renowned scientist. He's a researcher and a pioneer in the field of immuno-oncology. He currently serves as a director of the Loop Immuno-Oncology Research Laboratory at the Lombardi Cancer Center, with interests in developing novel cancer vaccines. He's also a biomedical scholar and professor, currently serving as the director of the Center for Immunology and Immunotherapy at Georgetown University. Through his years of experience at the National Cancer Institute, Dr. Khleif served as the chief of the cancer vaccine section. He was leading a national immunotherapy program where he was in charge of conduction of the clinical trials in antigen vaccines. He's currently using his extraordinary medical and research experience to raise awareness about challenges regarding COVID-19 and vaccination, something very pertinent to this very moment. And his lifelong experience includes directing development of national strategies and strategic programs, along with clinical healthcare systems at institutions in the United States, as well as in other parts of the world. Last but certainly not least, he's a biotech inventor with more than 100 patents in patent applications in the US and around the world. A prolific author, a beautiful mind, and more importantly, a really beautiful heart and spirit, and one of my best friends. I am exceptionally grateful to you, Samir, for joining us this evening. We got to unmute you, Samir. So now I think you're good to go.
Thank you very much, Vuk, for this generous introduction. One, and second, it's an honor to be here. It's first of all, it's an honor to be with you. And again, I could tell everyone, you know, the world is lucky to have you, and Serbia is lucky to have you, and I'm lucky to have you as a friend. So, and the activities that you do is really phenomenal. So, and thanks for the CIRSD for inviting me to be there. But more importantly, you know, one of my passions in life is to be with young minds, thinkers, and the leaders of the future. And it's a pleasure to be with all of you, to be here. And I am looking forward for your questions. I'm looking forward for the discussion. I was in New York just 2 days ago, and I was walking in the snow, and I went into a beautiful photography gallery. And there's this guy who was probably the most interesting guy I met during my trip. And it was literally during COVID, 2 days ago. I was wearing my mask, went in, and he was showing me the photography around, etc. I said, "So what's your name?" He said, "Milic." I said, "Serbian?" He said, "Yes, Serbian." I said, "Well, you know what? I'm going to be meeting with 50 Serbian students. So Milic sends you his regards from New York." Anyway, so Vuk asked me to talk a little bit about COVID from a health perspective, epidemiologic perspective, viral point of view, and how it affected the world and where we are on that. And I'll do that, but of course, I'm open to any discussions afterward. So I know there are medical students, but not also non-medical students. And I'm going to talk about it in general terms. So why COVID is important and why is it different than everything else we've been through? If you would have asked me a year ago or 2 years ago or 5 years ago, what is the healthcare nightmare for somebody who worked on public health for a long time, what would be your worst case healthcare nightmare for the world? The answer would be the following. One, if we have a virus or a pathogen that can transmit through air and transmit fast and lead to severe disease and death, but worse yet, lead to some patients that would not have symptoms because we can't discover the way it passes or it transmits. That would be the nightmare. This is what COVID is. So COVID is a virus that can transmit through the air, not food. You don't boil it or clean it, through the air. So you can be passing by someone, get the virus, has an R naught, and an R naught by definition of how many a person that's infected can infect people, between 3 and 5, which is pretty high. I mean, the highest in the world is measles, which is around 10 to 12. And it can infect people that 40% of them are not symptomatic. So you don't know whether they're infected or not. So they'll walk around and infect more people. And those that are symptomatic, many of them can die in a short period of time. That's a horrible nightmare. This is exactly what we got with COVID. It's the worst case scenario. Now, can it be worse? Yeah, it can be worse if the death is higher, and it can be worse if it transmits like measles, but this is one of the worst case scenarios. And this is why the world in the past year is as we know it. It changed. It's a different type of world. If 2 years ago or a year and a half ago, you ask anyone or you ask yourself, would you believe that you could live this way? You would have think that this is a Hollywood movie, but actually it's not. It is how we live. So viruses in general have been on Earth for millions of years, a lot of them. And I'm getting to why this is important. As a matter of fact, we have almost 200, 210 viruses that can cause diseases in patients or in humans, and majority of them are mild diseases, but some of them are major diseases. By the way, do you know how many viruses exist in the world? We have almost 10 to the power of 31 viruses in the world. This is a huge number, huge. So we have a lot of viruses. A lot of them are actually in soil or in plants or in animals. Now, why am I saying about the animals and I'm stressing on it? Because majority of diseases that occur in human from viruses come from animals. More than 70% cross species. And this is what happened in COVID. We believe it crossed species, could be from a bat. The WHO currently is making its investigation in China to come up with the origin of the virus. Do we know it 100%? We don't. The speculation now, it crossed from the bat to human, like, again, 70% of the other viruses that cause diseases in humans. There are lots of conspiracies about this. We can address them in a few minutes. But just before I jump into the disease, is it possible that the virus actually was manufactured? It is. It's very possible. Now, we do in the lab, as scientists, lots of changes in viruses to understand their behavior, to understand what diseases they can do, to understand how we develop drugs against them or how we develop vaccines against them. So is it possible that the Wuhan virology lab has done some changes for coronavirus and led to the development of SARS-CoV-2? Possible, but it's less likely. However, it is possible, but could have been then spread by mistake because they injected it in the bat and the bat was possible. It is not intentional for sure. It is not per design for sure, but could it be possible? This could be possible, but the possibility of it crossing species is much higher. What is coronavirus? By the way, there are more than one coronavirus in the world. There are 7 coronaviruses in the world. 4 of them they've been living with us for years. As a matter of fact, 4 of them cause common cold, just regular common cold. The 3 other coronaviruses, one of them is the SARS-CoV-2, which is what caused the COVID-19 disease. And the other 2 are the MERS and the SARS, which one came up in the early 2000s and one came up in the 2010. Okay, well, why did they not lead to what we have now? So the MERS did not lead to this. It was fatal, it was effective. The first SARS was fatal, but why didn't lead to what we have now in COVID-19? Why did not lead to pandemic that was announced mid-March by the WHO? For one reason that is very important. And this is one of those 4 reasons that I told you my nightmare would be, or any public health person nightmare would be, is that every single patient they infect is symptomatic. So accordingly, we can contain it. We know who has it, so we can contain it. When we have 40% asymptomatic in the COVID-19, we have no clue, or in the SARS-CoV-2, we have no clue who has it and who can spread it. So the viruses are there. We've lived with them. We developed vaccines around them. As a matter of fact, the first virus was discovered in early 1901, which was the yellow fever. And then there are lots of them that we know of, which is the 200 of them, but not every one of them caused this humongous pandemic because they do not meet those criteria. So we have hit with this pandemic. The world has changed, some of them to a good and some of them to a bad. Of course, the worst thing is in the US, we've lost 500,000 people. 500,000. I mean, today I was reading statistics. 500,000 is double what the US lost in 4.5 years of World War II in total. It's a lot of people to lose. 2.5 million people in the world. So it's a pretty bad disease that can change lots of behavior. Having said that, we've been very successful in understanding it. But when I say in understanding it, there's a reason why I'm saying that in understanding it, because it turned out that COVID-19 and SARS-CoV-2 is a very strange virus, not common, not usual for viruses. The science of it is a little bit strange, but more importantly, the disease of it is extremely strange. The spectrum of symptoms that we've discovered, and we looked and we found out that it causes in human is way beyond what we've expected before. And most importantly, way beyond any other virus. There are not too many viruses that we know that can infect so many of our organs and cause the spectrum of diseases and different reasons of death. I mean, this is not only a respiratory virus that can cause lung failure because of the either direct infection of the lung or the overactivation of our immune system, but can affect the brain, can affect the kidneys, can affect the GI system, with the gastrointestinal system. I mean, at the beginning, we were kind of shocked. A young guy, 40 years old, came to the emergency room with diarrhea that's there for 24 hours. He had 24 hours diarrhea, 40 years old, as young as it could be. 24 hours later, he was dead. I mean, that was mind-boggling from our perspective. So that's one. The good news is we now understand a lot of what this virus caused, but we absolutely do not understand everything, for sure. Now, the most important thing is the percentage of death from March till today have dropped significantly because of what we started knowing about the virus, and more importantly, how to treat the disease. One thing, though, that is very highly important about the virus is what we call now the long hauler, which means somebody has a virus, they got the disease, they got rid of the disease, but they continued having symptoms 5, 6, 7 months later. 30% of patients that have moderate to severe disease will have that. And this is something that we really don't understand. And the spectrum, which means that it's creating, by the way, a new disease that we did not know about, which is called post-COVID-19 syndrome. There are clinics now in the US that are specialized in what we call COVID-19, post-COVID-19 syndrome, is to treat what happened afterward, because it becomes now a very defined, unique disease. And some of those symptoms could be continuous fatigue, could be continuous weakness. The most disturbing is what we call brain fog, which is confusion, inability to concentrate. I know a couple of scientists actually that has it, and they really cannot concentrate. And it passes, it's there for like months. So we don't know what happened. Some people loses their sense of taste, sense of smell, and they still have that completely gone. So we don't know. There are lots of things to learn about this, but one of the most important thing, in my opinion, positive important thing that came out of COVID-19 is two things. The first thing is the amount of unprecedented development of science that occur around it. Unprecedented. For those of you who read medical literature, the first 9 months of the disease, we had 100,000 published papers on the disease. That's crazy. We've never had this before. The second thing is the international communications in science has been also in an unprecedented, at least trend. Third, which is the most important, I'll talk about this in a bit, we were able to develop a vaccine in 10 months. Now, one of my previous positions, I was special assistant to the FDA commissioner, which is Food and Drug Administration. My job was, I was brought into the FDA to develop a national strategy for the US to shrink the time that we develop drugs and decrease its cost. Every drug that we develop that is now in the market, it takes between 8 to 12 years. That's a long time. Now, we were able to shrink it, particularly in the past 10 years or 7 years, to become maybe around 5 years. This vaccine took 10 months to develop and be given internationally. We've never thought we can do that. Now, why this is important? Well, first of all, why did that happen? That happened because of the following. One is the major development in biotechnology in the past 5 to 10 years, major development in communication, major development in bioinformatics, which is computer power. So you can imagine that the virus was discovered in China, was sequenced all in totality within a week. And then the next day, all the sequence was in Boston, was in Washington, was in London, was in everywhere. And everyone started to work on the vaccine then and there. As you very well know, the first human genome in the early 90s, which is less than 30 years ago, took 13 years to sequence. Now we can sequence a whole virus within 24 hours. So that was a major part of that development. That's one. The second thing is the amount of money that was put in. So it was a lot of dollars that was pumped in to develop those vaccines. And third, of course, as I mentioned before, the major communication ability that we had. So when we look at this, if we are able to develop a vaccine for COVID-19 in 9 months, why can't we develop any drug in this period? So now there are lots of strategies that are being developed, including the Biden's administration, is to think, well, if we can really do that, and we did not know that we can do that, why don't we apply it to anything else? And why can't we develop those kind of drugs in a much faster way? So that's one positive thing about COVID. The second positive thing about COVID, it exposed the major gaps in healthcare systems around the world, not only in the US, around the world, is we really did not know how shortcomings that exist in our healthcare system can be so vulnerable. So that led in many countries to go back and think of how we can change this and how we can cross those gaps. So I would say these are two of the major positive things that came out of COVID. I mean, I could tell you about the third one, which is personal. I used to travel 70% of my time. I haven't done that for a whole year. And to a certain degree, short of seeing somebody like Vuk and have a drink with and a cigar, I'm fine with that. Other than that, I'll be happy to do it. I mean, look, I'm giving talks. For example, I gave a talk to Harvard on Friday, which is 2 days ago, on Friday. And it was 55 minutes, gave the talk, asked the questions, 300 scientists, all was great, and then done. If it was before COVID, I would have traveled to Boston in the snow, wasted a day and a half of my time to give that same exact 50-minute talk. So I would say that's positive. I think though, why am I saying this? I think all the behavior of this, it will be changing. I don't think it's going to continue the same or go back to the same ever. In my opinion, lots of those, and we can discuss this in more details, lots of those will change. So there are positives, and we were able to develop a vaccine. And the good part of that is not only one company or one country that developed vaccines, there are many of them. There are 60 vaccines under development currently in the world. 2 of them have been already approved in the US. At least 4 have been approved worldwide, or 5. And the ones are Pfizer, Moderna, AstraZeneca. J&J will be approved in the US this week, and then Sinofarm and Sputnik. Great. There are more coming, of course, and the more they come, the cheaper they will become. And they are highly effective. When you look at Pfizer and Moderna, they're 95% effective. That's unheard of in vaccines before. Measles was around 98% effective, but that's it. The vaccine against flu is 30 to 60% effectiveness. That's it. So when we talk about effectiveness of a vaccine, 95%, particularly in the pandemic, that is huge. And that's part of science. The problem, though, is threefold. One, human behavior. So the second, distribution of vaccine, and third is variants. Why am I saying this? Because at the end, can we go back to normal? The answer is we can. We absolutely can go back to normal, but we need what we call herd immunity. To be able to reach herd immunity, which means that the virus cannot spread from one person to another, spread from one person to another and just die off technically, or we live with it, we need almost 80%, 85% of the world having enough immunity. The virus by itself, if somebody got infected, that might not be sufficient, because we know for a fact today that many people have infected twice. And with the variants that I'll talk about in a second, they can infect more. So clearly we need to vaccinate between 80 to 85% of the world to be able to reach to the herd immunity. Repeat, where are the problems? human behavior. Conspiracy theories are so rampant these days, particularly about the vaccines, the refusal of vaccines. I'm sure in Serbia is very similar, because everywhere in the world is exactly that. And I have a program in Arabic language for the Arab world talking about COVID and vaccines and etc. And I get the same questions. So there is a tremendous amount of resistance to get the vaccines. Even in the US, some people are getting the first vaccines and they're refusing to get the second vaccine. Why? I got a message this morning asking me the following question. Is it true that 30% of the people that get the second vaccine die? I mean, it's really the way that social media is spreading those things is just mind-boggling. So that's one. The second is distribution and cost, and the disparity now between the poor and the rich. Probably most of the rich country would be vaccinated way before the poor countries, and that's issue that we need to address. And third, variants. We have now many variants that pops up. So what is variant, by the way? So all of you would know. Variants, it means that, when the virus replicates, when it infects me, and then I spread it to somebody else, every time it comes in our cell, it replicates. Every time it replicates, and the more it replicates, it accumulates mutations. Those mutations are random in general, and majority of them don't mean anything. So just to give you an example, you all heard of the spike protein. So if you look at the virus, on the virus, there are these spikes, those red spikes that beautiful that you see their pictures on. This particular protein is a spike protein. This is a very important protein. Why? Because this protein on the virus, it looks like a crown, is what the virus latch into our human cells. So when the virus comes into the nose, it comes and stick to our nose cells through that protein and get swallowed by the cell and get replication. So the spike protein had more than 5,000 mutations in the past year. So that's one protein out of all the proteins. So many other proteins have mutations. Most of those mutations are completely irrelevant. They don't do anything. Some of those mutations change the behavior of the virus, like the UK variant that you hear about now, which is called B117, or the South African variant that's called 351. So what happened is, on the spike protein, there will be mutations. This mutation now, by chance, it becomes significant. Why? Because now the spike protein can latch even stronger to our cell. And if it does, then it spreads faster. So this is what happened with those mutations. And this is why we call them variants. So they don't cause worse disease, but they cause faster spread. So with that in mind, can the vaccine cover new variants? And we were discovering that some vaccines can. Like the AstraZeneca is completely not effective against the South African variants. Novavax is fully ineffective. Pfizer and Moderna are effective, and they're less effective, but they're still effective against those. But can we expect them to be less effective against new viruses like the one that just appeared last week in UK, which is called the Bristol virus, the Bristol variant? It could be. Having said that, I was talking to the chairman of Moderna last night, 9 o'clock at night. We're just chatting. And those companies are making vaccines against those variants that could be used as a boost. So we will have things developed as we need to go. Vuk, I don't want to go more on that. I know you're starting.
It would have been like a fascinating lecture, like a 1 hour or 2 hour lecture, but I hope you're going to forgive me for interrupting you at this stage.
Please.
I'm going to dive into some questions that I prepared for myself based on some of the inputs that I received from the crowd in advance. So these questions may sound a little like of an outsider question, but these are the kind of things that occupies ordinary people, no matter how intelligent, but ordinary people mind. you were saying, and you explained it very well as to how did it come about so quickly, 10 months, this vaccine, right? And I understand that, and there are very good arguments. But now, some of these vaccines, and in particular Pfizer and Moderna, they involve this new technology, if I understand it well, the mRNA, sorry, technology. It has never been applied to humans before. These are the first mRNA, molecular RNA vaccines. So my question is, how can we be sure? Now I'm talking about Pfizer and Moderna, because Sputnik and Sinofarm and AstraZeneca are different, if I understand well. But how can we be sure that Pfizer and Moderna, with this novel technology that has not been tested before, and it's been only under research and development for 10 months, and we don't know what's going to happen in the next 10 years. Are there going to be difficulties that prove to exist down the road? How can we be so confident in such an untested concept of vaccine making?
So, so there are some factual issues that I'm going to correct. One, it's not true that it hasn't been tested before. RNA vaccine existed for the past 10 years. Moderna has 8 different vaccines for different infectious diseases in the same technology, like CMV, like some of the tropical diseases. So it's already there. Plus, those two companies, BioNTech and Moderna, are cancer vaccine companies, and they've generated the RNA vaccine originally for cancer patients.
But yeah, I know about Pfizer, but how about Moderna? I heard that this is like a first major project that is being disseminated.
Major project, yes, because there's never been a reason to create a billion vaccine. But Moderna started this technology 10 years ago. And Moderna created 8 other vaccines for other infectious disease in the past 8 years. And they've used this vaccine in also cancer patients for cancer vaccines. So it's not new. It's been tried in human before. That's one. The second thing is, which is really the most important point, Vuk, that you mentioned, how do we know that we will not have long-term effect? So let me back up 1 second. The technology of vaccines, whatever it is, it has exactly, and it plays and works in exactly the same principle, which is putting a piece of the virus, piece of a protein of the virus in patients or in human, and stimulate the immune system against that piece. So now the immune system is stimulated, so when it sees the virus, it recognizes that piece, so it kills the virus, right? That's the principle. The difference between between company and company is how you give that piece. Either you can give it like a protein, like Novavax, or you give it like DNA, like AstraZeneca, Sinofarm, or J&J. Because what they do is they put the DNA in a vehicle called the adenovirus, which is another type of virus that they kill, but they put the DNA of the COVID vaccine in it, and then they give it in. So you're giving a DNA anyway. When you give RNA, the RNA, after you give it, it degrades completely of the body in less than 48 hours. You don't have it anymore. It's gone. Accordingly, there is no way that it will have itself long-term effect, because the rest of the effect is only the vaccine effect, like the rest of other vaccines. The last point, which I hear a lot, is, oh, they're giving RNA, it's going to change our genome in the next 10 years. Scientifically, RNA cannot integrate in DNA. I mean, it just can't. There's no way that RNA can integrate in our genome. So basically, it cannot do it. So one, it degrades completely. It disappears from the body within 48 hours. So there's no long lasting. Second, it already made the effect exactly like any other vaccine. Third, it's been used in human before for the past 10 years. And fourth, which is the most important, it does not integrate in the DNA. Accordingly, it cannot change the DNA.
Got it.
Fifth, I took it.
Well, thank you. That was the fifth one, was probably the most convincing one. I'm going to ask you now about our current situation in Serbia. Serbia is one of the countries that made a special arrangement with China sometimes during this pandemic to effectively be one of the third stage clinical trial countries for the Sinofarm vaccine. And thanks to that, many doses for a country that has only 7.5 million people, we received like a humongous supply from China of the Sinofarm vaccine. And one could argue whether this was some kind of a Russian roulette or a gambling on behalf of the Serbian government, but it looks like this gamble had worked, and thank God for that. Now, this Sinofarm vaccine is generally available in Serbia. You may have to sign up and to wait a little bit, but it is available. Theoretically, other vaccines are available too, Pfizer and AstraZeneca, but we received only very small quantities of this. Another reasonably available vaccine is Sputnik. So Sinopharm and Sputnik, for all practical purposes, about 90% of our population, if they want to take a vaccine, they can go for Sinopharm and Sputnik. That's our current situation. What is your advice? Obviously your advice is to take vaccine. Now, which vaccine to take? And if you could answer this not only from scientific point of view, but also from the point of view of practical considerations, like, oh my God, tomorrow they may need a vaccine passport. They may require us to show certificates of vaccination in order to travel to, I don't know, European Union or the United States, and they may not accept anything other than Pfizer, say, or AstraZeneca. They'd ignore Sinopharm and so on and so forth. So these are all kinds of considerations that are, fluctuating in our minds as we're making up our decision whether or not and when and which vaccine to take. So what is your recommendations for us who live in Serbia under such circumstances?
So first of all, whether or not is clear. It's clear cut. Absolutely 100%, every person above the age of 18 today should be taking the vaccine. I mean, I would not hesitate a second. And as you and I discussed, I took it, I'll give it to all my family, I'll give it to everyone that I know. So that's one. Because the possibility of getting COVID is pretty high, and the possibility of suffering from COVID is very real, even in young people. So that's one. Second, so what is the difference between Sputnik and Sinopharm? And that's also a very important question that I get asked a lot. The only thing I would tell you from a scientific perspective, I cannot comment on Sinopharm efficacy because there's nothing published yet. So until it's published, then I can comment on it. Having said that, a vaccine is better than none, particularly the Sinopharm vaccine, and I'm talking about this now, is a technology that has been in vaccines that has been used before. We know it generates good immune response, etc. So do we wait until the clinical trials? I would not. If you have it, I would take it because a vaccine better than nothing. The Sputnik, the difference between both of them is one adenovirus with a DNA in it that creates it, and the other that create the protein, and the other one is a dead COVID virus. So either of them we've been using for a long time, and we know it works. The Sputnik vaccine is effective. We know that because it's published 2 weeks ago, and it's 92% effective. So it's as good as the Pfizer vaccine. So the answer to your question is one, I would absolutely take a vaccine. Second, whatever is available. So I would not choose one or the other because we know that the Sinopharm now is given to lots of people in the world, and we know it generated good effectiveness. We don't know exact numbers because it's not published, but also it's safe. So I would not hesitate to take them, and I would not spend too much time to actually decide on it.
And what about the following? If you go and take the Chinese vaccine,
Yeah.
And then after, I don't know, 30 days or 40 days, you make a test, and for some reason, you don't have antibodies. You fall into this category of 8% or 10%. You're unfortunate and you haven't developed antibodies. Can you take another vaccine afterwards? If your Chinese vaccine doesn't work, can you go on and take another one like Sputnik or Pfizer afterwards without major consequences?
Yeah, the answer to that is you can, because this is what we do with flu virus, right? With the flu vaccine. We take it every year because the amount of immunity that you got, the fear is gone almost. So technically you can. This is what we do with tetanus, right? So in tetanus, when you take the vaccine in tetanus, after 5 years, if you get injured and you go to emergency room, they ask you how long ago you got your tetanus vaccine, right? And they give you another shot of tetanus vaccine. So it doesn't matter the technology, Vuk. This is what I'm trying to answer, because every single vaccine, in principle, it works the same. So if you can boost it with another vaccine, it's absolutely fine. Having said that, currently, a week ago, it started, there is a clinical trial that started in the UK, which is called the mix and match clinical trial, to start to see whether you can boost with a different type of vaccine. And the answer to that most likely is going to be a good clinical trial, and it's fine, because logically that's the case. Having said that, something very important. Adenovirus vaccines can generate antibodies against the virus itself. So it might be difficult to boost them in the future for variants. And this is why you may need to be boosted with a Pfizer vaccine against a variant, new variant, or a Moderna vaccine. And technically now Moderna and Pfizer are doing this, speculating that this is what's going to happen.
Very good question now. Very good observation that is leading me to another question. Okay, we're now going to go through months and years of vaccination. I'm saying years because we want to make sure that the whole world is vaccinated, and poor countries are going to be in a much more difficult position logistically and otherwise to make a massive vaccination of their respective populations. But let's say we're able to do it after a while. Now, what is your opinion? Is COVID-19 going to be, by means of this vaccination, eradicated like polio was eradicated? And it's going to become like variola vera and so on and so forth? Or is it going to become extinct and we're going to, just going to be discussing it historically and debating it historically? Or do you think that something more complicated may happen in the future with this particular virus?
I think this is my crystal ball, right? I'm just going to put on. So that's a great question. And let's make assumptions. If variants are not going to happen fast, and by the way, a reason to be vaccinated as fast as possible is to prevent variants from happening. Because when you get vaccinated, then the virus will not be able to replicate from one person to another. So the possibility of developing variants would be decreased. So this is why the most important is to vaccinate as many people as possible within shortest period of time. Okay, so that's one. But let's assume that variants will not happen. I would say unlikely that we would eradicate the disease, but we will live with it. The number of people that would be infected with it are going to be pretty small. And because we have lots of immunity, the symptoms are going to be less. So the possibility of dying would be going away, but the virus will be around. But it's not going to be really a major problem for anyone. That's my prediction. If variants will happen and they will become differently behaving, whether in the disease part, which we haven't had any yet, right? The disease, the pathology is still the same. It's a spread of infection, or that those variants will become not amenable or susceptible for the immune response that would happen, then we might have it for a long period. And we will know that within the next 24 months.
24 months. So there's still a lot of uncertainty ahead of us, even with all these vaccines coming out.
Because in 12 months to 18 months, we'll probably vaccinate a lot of people in the world. And afterward, we'll start seeing those behaviors will happen.
Right.
Sorry, go ahead.
No, go ahead. Finish it up.
Yeah, if variants are not happening fast, we may be able to get to a normalizing state, not normal, I would say within the first quarter of next year.
So another year of abnormalities is ahead of us. Actually,
it depends what abnormalities mean.
What my next question was going to be about. By the way, we're going to be talking, you and I, for about 10 more minutes, and I encourage all the participants to start typing questions and sending questions to the chat, so that we can be efficient once we start the student Q&A session. So,
and Vuk, by the way, before you ask me the next question, you asked something very important about vaccine passports.
Yes.
Whether it's going to happen or not.
Yes.
I doubt it.
So you don't think that there's going to be a situation where the United States government, for instance, is going to say you can only come to the United States if you are A, vaccinated, and B, vaccinated with the following list of vaccines?
I would say the first part is yes, probably. The second part is unlikely, but they may still demand a test for a certain period of time.
So this is actually also tying in nicely to the next question. Okay, it's going to be either resolved or significantly simplified in the next, say, 12, 18, maybe 24 months. But now to move away a little bit from science and to get to life, what are the aspects of life that you think are not gonna ever go back to normal as we knew it prior to the outbreak of COVID-19?
Yeah, so that's something that I think about very, very frequently. And there are many aspects that I believe it will not go back, at least for the short period of time. And there are aspects will never go back, period. I'm going to start with the latter. Office work will never go back to where it was. I think there are lots of behavior, which is called work behavior, will change forever. Which means, do we need to have those large office place where people go and work in, whether you're a lawyer or you're a consultant or you're whatever? I think that's completely gone. And with that, it's going to be a major office real estate industry that's not going to be there anymore. So that's changed, because the way now business is happening, and by the way, people are finding out that they're way more productive doing business like this than driving an hour and a half to the office, stay there for a few hours, waste time with coffee and come back. So that is changing. And many companies today are changing that. Actually, not Snapchat, I think one of the major companies today announced that they will never go back. I think either Snapchat or one of the music companies, they will never go back to office. Everyone can work from anywhere in the world, and period. So it's over. So that's one. I think big part is going to change conferences. I don't know whether we're going to go back to any time soon to large conferences where we have 5,000 people or 25,000 people. That might also change for a long period of time. The ones that we will be living with for a long time is the masks. So this is something that will be there for I think many months, if not years to come. So many of this is going to change. Now, in medicine, I will tell you, one of the major things will change is we discovered in medicine that we really don't need patients to come to the clinic to be seen every time. So probably 50% of that will go. And telemedicine is going to be something that would be the norm in the future. So many of this is going to be happening, in my opinion.
That is fascinating, and I'm going to ask you another question about the consequences. You said that there has been an unprecedented level of cooperation around this, and you hailed it as one of the breakthroughs, as one of the positive aspects. Now, has there been a same level of cooperation between the United States and Chinese scientists? What is the current level of cooperation between scientific cooperation between the US and China? Because a lot of people are talking about, not just for this COVID thing, but it's been like a bigger trend, this emerging and strengthening rivalry between the United States and China. And a lot of people are talking about the new Cold War, especially in the field of technology. Now, what is your expectation for the US-China scientific and medical cooperation and relationship in general in the years ahead?
So this is a very, very sensitive question on many levels, Vuk. One is, so there was a problem from China-US cooperation on scientific level for the past 3 years that was blown up completely almost 2 years ago by firing many scientists, American scientists, from many US organizations because they were cooperating with the Chinese. And the reason is that all started from espionage, scientific espionage from China on the US that was discovered by the US government. And the Chinese did a couple of programs, which is called the Thousand Light programs, that given funding to US scientists in return of scientific exchange of ideas and information. And that was found to be more espionage driven. And accordingly, the US government started putting very strict rules on collaboration with China. That thing did not change so far and will probably continue for some time. So it's not really there. It is there, but a much lesser extent than we have it. And it might not, and that is affecting future collaboration. Having said that, the majority of the openness was the publishing openness and the openness, which means getting the virus sequences and put it on the internet, because this is what people do these days. And that led to exchange information. Mm-hmm. But for cooperation, it's decreased in the past 2 years significantly because of that.
That's not terribly encouraging, but I've got two more questions. And I hate that we're already almost at the end of our part of this session, but these two questions I gotta ask. Number one, you're like at the forefront of global research when it comes to combating cancer, and especially in the context of immunotherapy. So maybe a few days ago, there was an article that came to me. It was by Sky News, and the title of this article is "Breakthrough mRNA Vaccine." We talked about mRNA vaccines in the context of COVID. Developed for cancer immunotherapy by Chinese scientists. So my question to you is not related directly to this article, but to the vaccination against cancer, and in the context of this gigantic breakthrough that was made in the past 10 months because of COVID. How optimistic are you about development of cancer vaccines in the foreseeable future. And do you think that cancer is going to become a curable disease in our lifetime?
So let me just clarify one thing that's very important. When we talk about cancer vaccine, is different conceptually than vaccine against COVID or virus, because cancer vaccine is not to prevent, is to treat. So it's part of a treatment to generate an immune response to treat cancer that already existing within a patient. So the second question, how optimistic I am that cancer will be cured within our lifetime. I'm going to tell you a story. So as you know, I was the director of the Cancer Center in the state of Georgia 3 years ago for a few years. And I got a call almost 5.5 years ago about President Carter, who has had melanoma and the melanoma gone to his brain. So President Carter was 90-year-old then. And for somebody that has melanoma that gone to their brain, the possibility of them living 6 months to 8 months is almost 0%. They will die within 6 to 8 months. President Carter is alive 5.5 years later. The reason he's alive 5.5 years later is because of something we call immunotherapy. So if it can cure President Carter, and we know it can cure many other patients, then clearly this is a major step towards a much larger cure for broader type of patients. And this is where we are now. So the advances that happened for cancer in the past 5 to 10 years, and actually the Nobel Prize 2 years ago or a year and a half ago, was because of part of the immunotherapy. But that was only one drug of immunotherapy, and we have 900 coming to the market within the next 5 to 10 years. So I would say the possibility of us seeing more and more patients cured from cancer is extremely high, because immunotherapy led to a major cure in patients that were dying within 6 months. So I'm very optimistic on that.
Well, thanks for that. And the last question I'm going to ask you is for the sake of our medical students, that some of these students present are medical students. And since the US medical schools range amongst the top, if not the top in the world, however, they're amazingly expensive. This is probably the most expensive education that you have in the world. If somebody is studying medicine in Serbia or elsewhere in the region of the Balkans, which is not a terribly rich region, and if somebody is a good student and somebody really wants to go to the US for medical school, and it's now prohibitively expensive and difficult to enter. I know that in the past you have been working very hard on bringing in students from Jordan and elsewhere from the world to the US to study and to become doctors in the United States. What is your recommendation for medical students from our part of the world if they're dead set on wanting to go to the US for studies? What is the way to go?
So first of all, I would not advise people to go and study medicine in the US. They can study medicine in their own countries. And they can graduate with medical degree from their own country. I'll tell you what I did. I studied medicine in Jordan. I graduated from medical school in Jordan, and Jordan has a similar system to Serbia. It's a 6-year medical school. And then you come to the US to do your specialties and get your boards, which is your primary specialty or your secondary specialty or subspecialty and everything. Now, the best way of doing that is to finish medical school. And then it's not easy to get into residency programs, particularly good residency programs. And it's important to be in a good residency programs for a foreign medical graduate And a foreign medical graduate need to also pass some tests, which is called USMLE or other names now, to be able to get into residency programs. So the best way is to finish medical school, go to the US, and I did the same. Do research for 1 or 2 years in a good, reputable place. And this will provide you with two very important things that are highly important in the US. One, publication, and second, good recommendations, particularly connection of good recommendations. But also a third one, a sense of commitment. So these are the things that I would advise, Vuk, for anyone that would be wanting to continue their medical education in the US.
Well, thank you very much for this. And now we are going to move to students' questions. And lots of questions have come so far. So I have a range of questions here. And the first one would be from Anna Brankovic. I am going to let Anna, ask you a question, and I just need to figure out how to do this. So where is Anna?
Hello.
Anna, can we hear you?
Me?
Yes, we can. So please go on.
I have one question. Since there are constant stories that aim to discredit vaccines, I'm interested in whether it is known that vaccines can affect fertility in men and women. And if so, in what way can they affect it?
The answer to that is no. No, and period. There is no reason for a vaccine to affect fertility, scientifically or logically. We have almost 70 years of experience in vaccines. And as I said, vaccines work exactly the same, and it does not affect fertility in any way, shape, or form. And there's no reason for this one to do. Either men or women. And by the way, it's not only fertility. It does not affect also sexual performance, because I get that question so common, even more than fertility. It does not.
Okay, thank you so much.
Yeah.
Well, thank you for this answer, Samir. It's really encouraging. So the next question is going to be asked by my, well, not namesake, by surname sake, Yeremich. Philip Yeremich has a question for you, but I just unmuted Philip. We need to ask him also to turn on his camera. Philip, are you with us?
Yes, I am. Just a moment. Can you see me?
Yes, I can. We all can see you.
Great. So, what is your opinion about production capacities for vaccines? We have mRNA technology that is, in my opinion, very powerful weapon in our hands to fight COVID-19 and many other diseases in the future. So the biggest problem was to find delivery systems that will work to deliver mRNA to our cells. So we have it now, that lipid particles. So are we ready to expand our production capacities in the future so we can easily fight new variants of virus? Because messenger RNA is really easy to edit and to adapt to fight new variants.
Yeah, so the answer to this question is, this is one of those things that, at least in the US, we're trying to struggle to enhance. Moderna will be producing, for example, will be producing 1 billion doses this year and 2 billion doses next year. So the question, can we even make that faster? Well, between Moderna and Pfizer, we're probably going to have 3 billion doses this year. So, but at this stage, today, without further manufacturing facilities, it's going to be very difficult. I know the government is working on supporting further, at least in the US, further manufacturing facilities. other companies, like take Sputnik. So Sputnik now is the Russian sovereign fund is contracting with multiple different companies in the world to have local manufacturing facilities within those countries to be able to produce that. So that could happen. But Philip, this is one of those things that I talked about, whether good or bad things that we learned. This is the gap that we discovered. We never thought we're going to need those kind of manufacturing facilities. Now we know, because we don't know when we're going to be hit with a second one or with a different one. So all this will change because it will make those manufacturing much cheaper and more effective. And the RNA technology will definitely do that. So that's something we're working on.
And in the future, we will be ready for something like that again, and
That's the
we
intention.
will be well prepared. And
That's exactly the intention.
Just one more thing about vaccination strategies, because different countries have different strategies. Slovenia vaccinated a lot of people with only one dose without providing them second dose. This is, I think, good for economy and for healthcare system, because they will not have a lot of serious cases, and pressure on the health system will be low. But what about this strategy in as third world countries, poor countries? Can we make some plan in the future that can provide just one dose of the vaccine to poor countries? Because
Thank you, Philip. Thank you. The question was very good. Now, Samir, please answer.
So that's a great question. And the answer to that is there is a humongous risk to give one vaccine for the following reason. And I'll come to the political issue in a second. But if you give one vaccine, it means that you are half vaccinating most of the population. So the amount of immune response that's happening is weaker in majority of the population than if you give two vaccines that are much stronger. This is where potentially we can develop more variants or resistance. And this is why majority of us as scientists don't believe that this should happen. This discussion happened actually in the Biden administration, and we were very much against it. But you can say, well, is it better to vaccinate half of the population than most of the population, than part of the population, halfway or part of the population? You understand what I said? And the answer to that is potentially yes, with that risk, and that risk might be really, really bad. So the current strategy is, well, if you have the vaccines, vaccinate everyone. And then if you get a different kind of vaccines, as Vuk suggested, then you vaccinate them with a different kind of vaccines. But I would not today advise for one vaccine versus two because of the risk of developing variants much faster and resistant strains.
Thank you, Samir. The next question goes to Sava Mitrovic. I'm going to unmute Sava in a second. Sava.
Thank you, Luke. Can you hear me?
Yes, everything's great. Just go ahead.
This is great, a lecture, and I'm a political scientist, and this is definitely not my field of expertise. But I have one question. Do we know how long vaccinated people are protected from the virus? Because if immunity lasts only for a few months and we prolong this vaccination process too long, can the whole process fail? And the second question, can people after vaccination, vaccinate people still transmit the virus?
Okay, so these are very good questions. The first question, how long does it last? We don't know that because we don't have time yet to know, right? So it's been, the vaccine has been a few months only, so we don't know that. But there are ongoing studies to check on how long the immunity would last. And worse come to worse, if the immunity decrease, we'll boost it. Similar to what I said about tetanus or otherwise. Regarding your second question, what was the second question again?
Can vaccinate people still transmit the virus?
So this is the other thing is we don't know, but so the studies are ongoing if we can transmit or not. The only thing that we know now is data that came out of Israel this week that looked into, because they vaccinated more than 80% of their population already, is whether they can decrease transmission, and it looks like it does. Potentially 80% decrease transmission with that Pfizer vaccine, but this is only observational study, is not properly done study, but this is a pretty good hint.
Thank you. So we should maybe wear the mask after vaccination.
100%. You absolutely should wear a mask. Not only because you might still transmit, but because we don't know if you're one of those, again, 10% that did not get the immunity, and you still can transmit even if 100% of the vaccinated with immunity do not transmit, right? And not everybody is vaccinated in the country. We have to continue to wear masks until we know that everybody is really properly vaccinated and we cannot transmit anymore.
So Samir, my question to you is, when do you expect that we're going to be able to move around without masks, to go on a plane without masks, to go places without masks? Because masks are terribly irritating, especially for those of us who wear glasses like you and I. Like, what is your expectation? When are we going to lose our masks?
So listen, Vuk, I'll tell you, I'm a physician and I wear a mask a lot in the hospital. When I went to New York, which was the first trip ever I get in 9 months or 10 months, and I had to go to New York, I took a train and I wore a double mask in the train. And I was irritated. So I am the person that wears mask all the time. Having said that, so to answer your question, I don't believe that mask is going to go away completely in the near future. I don't believe you're going to be riding a flight without a mask for at least the next year and a half, if ever, because lots of people might just continue doing that regardless. But it might be changing in places like restaurants or some places that you know it's more safe, but not before the first quarter of next year.
Great. Now, the next question goes to Nikolina Radonic. I am going to unmute Nikolina.
Okay, I think everything is okay, right?
Yes.
Okay, I have a question for Dr. Samir, and it goes like this. How do you, as a healthcare transformational leader, see the transformation of healthcare systems in the future? And like, what could be some of strategic steps of governments in future in order to prevent some possible healthcare crisis in the next period?
That requires another 3 hours, but I can tell you at least 3 important points, Nikolina. First one is the absolute importance of a unified healthcare information system. That is crucial. That is very important. And this is one of the major problems that we're dealing with now in the US and outside the US. That's one. Second, the importance of early intervention, particularly in understanding the biology of anything when we talk about viruses, which means sequencing. So which means that we should have the facilities and the abilities to be able to test and sequence immediately, because that would lead to a much better containment of the disease. Third, which is probably one of the most important things we're dealing with now, is a centrally controlled distribution system of healthcare supplies. That doesn't exist currently. And it is very important that this will happen in majority of the countries. This is my top 3. Having said that, I can go down the list of the gaps that we discovered for another 3 hours and tell you about, but at least these are the most 3 important things that I could tell you now.
Okay, well, thank you, Dr. Samir.
Thank you very much, Samir. And the next question goes to Branko Justibek. Branko, are you with us?
Good evening. Just let me know if everything is working. Can you hear me?
Everything is great. Just go ahead.
Fantastic. Well, I'll make my question quick. So when we talk about containment measures and in particular national lockdowns, which many governments worldwide have adopted. Have lockdowns so far been successful in combating the spread of the coronavirus? And if so, was this a Pyrrhic victory for governments, bearing in mind lockdowns significantly contributed to the economic crisis on a global scale and deterioration of people's mental health? Yeah, that would be my question.
And the answer to this question is, it depends. So did lockdown, so the first question, does lockdown help? The answer to that is absolutely no doubt. No doubt. Look at any country, when they locked it down, it led to drop in the cases and drop in the death. But do we need lockdown? The answer to that is absolutely not if we maintain proper social behavior. So look at countries that really worked very, very well. And this is one of those things that we have to learn. And going back to the previous question of Nicolina, these are the things that we learn in not only health system, but policy. Look at a country like Singapore. Singapore has 0 cases, 0. Not 1, not 2, 0. They don't have lockdown, but they have proper social behavior policy. And it's followed. Now, when we got those social behavior policies loose, a case in point, Sweden, that thought, okay, well, let's get people to determine by themselves, we had a disaster, right? So this is where things will actually has to be put in balance. It is the balance between government policy, social behavior, and proper implementation. Because if you have the proper implementation and people are following the proper social behavior, you don't need lockdown anywhere. But that's the issue. That's the problem. And this is where lockdown would be effective. But lockdown is very, very, it's a Band-Aid, right? It's a very short measure. You lock it down, you drop it, you open up, everybody goes to bars now. Cheers, cheers, or go to weddings or whatever. And then we have another surge. This is where the problem is. So people have to be more responsible, like other countries, including the Southeast, where they're Southeast Asia, which is more responsibility within the countries because of certain behavioral thoughts and certain education, whatever. But the most important is for that triplet to be there. In this case, economy will continue. But yes, the lockdowns would affect the economy in a horrible way. And I've been working with some countries like Jordan. They resisted locking down because of the economy, but they had to lock down, so they dropped back, right? But in this case, it would be very difficult on those countries without proper education and social behavior that need to be changed.
So would you say, just a very quick follow-up question, would you say that the reason why the many lockdowns in UK failed is because of the lack of cooperation, because people were not disciplined? Because UK had now, I think this is the 4th lockdown, and really there are no major, well, there are, I cannot say there are no improvements, but it's still not a significant, we still do not see a significant improvement. So do you think this is because of the lack of
100%, 100%. Now, Branko, as I said, if you look at any lockdown, if you have a peak, the curve actually goes down after a lockdown. The problem is, after you open up, do people maintain that or don't maintain that? And this is why it fails.
Great, thank you. Now the next question goes to Tanya Petronievich. Tanya?
Hello?
Hi.
You hear me? Yes?
Yes, we
Okay,
can.
I have question. Quick question. There are several studies about COVID-19 increases miscarriages and intrauterine fetal death. So I need your opinion about that. Thank you.
I'm sorry, I could not hear the question very well, Tanya. You said miscarriages.
There are several studies about COVID-19 increases miscarriages and intrauterine fetal death. So I will ask you for your opinion. Yeah. Intrauterine fetal death.
Intrauterine infection, right?
Infection, you said?
Yes, fetal death. Yeah.
Okay. So we have to be very careful. And actually, we had a call last night. We have this weekly national call that we discussed those things, and this came up. We have to be very careful about linking. When you vaccinate 20 million people at once, things will happen, which means people are going to die. because if you don't vaccinate them, they're going to die. They're going to be hit by a car. They're going to have abortions, and they're going to have ITTP or whatever, right? So we have to be very careful when we link the causality to it. Is it higher than usual or it is not higher than usual? For the abortion one, as of yesterday, we know it's not higher than usual. The FDA, which is the Food and Drug Administration, is monitoring every single vaccinated person post-vaccine. There is nothing actually that led to the belief or any data that shows that there's an increase in abortion that is linked to the vaccine so far, right? Is it possible? We don't think so. There's no reason for it. So far, the US, and by the way, Israel, the same thing. So Israel found no relationship whatsoever with abortion. And the person from the Israel Minister of Health was with us on the call yesterday also because they did that. So there's no link so far that would show that. And second, we still in the US recommend that pregnant women should take the vaccine, because if pregnant women got the virus, as you know, the complications in pregnancy is way higher than normal population, and the severe side effects of the virus is way higher, and potential death is higher.
Thank you. Now the next question. Thank you. Thanks a lot. Thanks both to Tanya and to Samir for this answer. Now, next question goes to Mattia Stefanovic. I'm unmuting Mattia, and he should turn on his camera as well.
Hear me properly?
Yes, we can hear you. We can't see you though, but hopefully that can be worked out too.
Apologize for that in advance. I have noticed these days that the video for some reason isn't working, so apologize for that.
No problem. We'll take this as a good enough excuse if the question is smart. So go ahead.
Okay, thank you.
Okay.
Thank you. First of all, thank you for an amazing lecture. It's been really wonderful listening. My question is, would you say, well, apologies. At this point, I'm really pro-vaccine because also some of my family members have suffered through, and some of them have lost, unfortunately, their lives. But there's also a slightly political skepticism when it comes to our government and the way the whole vaccine system is being done here. Would you advise getting the vaccine in your home country, or finding potentially alternative ways in doing it in your second country, in your host country where you're currently residing, and that's not Serbia?
There's again, I don't know what the exact political things that you're mentioning. Having said that, it is very unlikely that a vaccine, especially brought by a country, would not be an authentic vaccine, because the government will fully fail in this case, if that's the case. So I would say, in general, I would take the vaccine where you are, and the sooner the better.
Okay, thank you.
Great, thanks. The next question goes to Sarah Barisic. Sarah?
Hello, everybody.
Hi.
I have one question. Can a person who had a stroke receive the vaccine?
Yes. Yes, can.
Yes.
Yeah. Thank you.
That was very short and that was very efficient. Now, the next question goes to Alawi Al-Hakan. Is our guest.
Can you hear me?
Yes, we can.
Right. Thank you first for this great seminar. Dr. Samir, you said that 90 to 95% of the people need to be vaccinated. Does that mean that the vaccination will become obligatory for everyone? And whether it will be or not, what about those who refuse to get vaccinated? Thank you.
So I did not say 90 to 95, Alawi. I said 80 to 85.
Oh, I'm sorry. 80 to 85.
There is a reason. There is a reason. Actually, there is a science behind that. The way we know when to get herd immunity is dependent on two things: the effectiveness of the vaccine and the R naught of the virus, which means how many a person can infect. And that's calculated. So for the US, it should be between 75 to 80, because the Pfizer and Moderna that are US are very highly effective. So to answer your question, of course, that's a political question. Should the vaccine be mandatory? And the answer to that is, in my personal opinion, and I'm not a policymaker, and if I would be, I would have a different opinion, is yes, because we have mandatory vaccination for kids in all countries in the world, by the way. You cannot not vaccinate a kid. That's mandatory. And the reason is to protect the kid and protect the society. Having said that, at this stage, because this is an adult vaccine, we all believe in freedom of choice. Like smoking, the problem is we have a freedom of choice in smoking, that you can still smoke and get cancer for other people. But at this stage, it is not mandatory. I would believe it will never be mandatory, particularly if we can control it. If we reach a level where it's out of control, then maybe some laws would be implemented.
Great. So the people will be sanctioned, right?
Is what? I'm sorry?
So the people will be sanctioned if it becomes mandatory.
Well, I mean, this is very difficult to answer, right? Currently, if a person has cancer, if a person smoked and caused cancer in somebody else because it's a secondary smoking, they will not be sanctioned. So, I mean, those are really policies that has to be addressed within the current context of the problem of public health that we are in. So it's very difficult to say that, and it's going to require a lot of discussions and back and forth. And more importantly, in democratic society, it's going to be very difficult to be implemented or taken as a resolution in any parliament in a democratic society. It's going to be very difficult. Okay. So this is very hypothetical.
Well, it's very hypothetical for at least for us who live in Serbia, because you're just referring to democratic systems of governance. So one day we might be there, and then we're going to worry about it. Now, the last question goes. Otherwise, I would have closed it, but I found this question so interesting, and this is going to be the last question. And Luka Božović is going to ask this question.
Can you hear me?
There's some kind of echo.
Just wait a minute.
Yes, oh my God.
Can you hear me now properly?
Yes, we can.
First of all, good evening. I would like to thank you for a great lecture. And I'm student of Faculty of Law, University of Belgrade. So obviously my question won't be medical. And I have a question for both of you. What do you think, what is the most important but untold thing about COVID and whole situation related to this virus? Thank you.
The most important untold, you mean like hidden?
Untold, hidden, or just untold?
Or not generally known. Not generally known, right?
Yes, yes. Or I don't think like intentionally hidden, but untold, just that.
That's a great question.
Thank you.
So for sure, I would say that vaccines do not have chips put by Bill Gates to follow people and then turn them off so they let them die. That's for sure not the case. Okay.
Yeah.
You know, I think probably. First of all, there's nothing untold that I know of. Okay, nothing. I think there are things that might not be known to the public because of no access to information, and those would probably be majority of them vaccine related, especially similar to the questions that we are getting now. So I would tell you one thing. So we can close with that, particularly that the vaccine is a major issue, is that the vaccine of COVID, based on all the studies, and I've reviewed all of them, based on all the studies that have been done, and what we call post-vaccine monitoring, which is large population monitoring, there is nothing so far that we've seen that is different than any other vaccine we took all our lives. And there are 45 vaccines that as human we can take from. So nothing. It does not cause any of the diseases or long-term diseases that we've actually thought about. The second thing is the virus itself, Luca. I would say the things that we know that probably will not be public, which is what Vuk mentioned, is we're not going to be going to normal within 2 months or 3 months or 4 months, or even, in my opinion, a year. Normal as we were used to before, which is going to crowded places, go to restaurants freely, go to airports without mask. I mean, again, we're a year into it. I was in Union Station. I don't know if any one of you know Union Station. I know Vuk knows Union Station, but I was in Union Station in Washington just 2 or 3 days ago. This is a place that you cannot step into at 2 o'clock afternoon. There were no one in the middle of the week, not even a weekend. So I don't think we're going to go back to normal, and lots of behavior will be changing forever, as a matter of fact.
Well,
Thank you.
So I didn't expect the question to be directed to myself, but you did ask the question to me as well. I think, well, at least for me, the biggest untold story of this whole thing is how this entire global crisis and national crisis actually brought your life to a halt in certain ways, and allowed you some time to pause and reflect on your relationships that have all of a sudden become distant and more difficult to consume, except for the most immediate family. I actually spent 3 months, 4 months in a lockdown with my wife and daughter. And I just realized that I was like so much missing out on so many things before COVID. I would be spending time with my daughter, maybe like an hour, 2 hours a day, prior to being forced by means of this lockdown to spend like the whole day with my family. And that kind of opened up my perspective on things that I haven't really had a chance, or really haven't had a time to think about. So the world is not going to go back to fully normal. The world is not going to go back to what we had before. But I think that since this crisis has not been completed, it's not over yet. Use it. You are not going to have this much time for you and for your immediate family again soon, if we're lucky. So use it to look around you, but like the most immediate surrounding, in a way that you haven't really had a chance to do that when you were like racing and chasing and going after career without taking breath.
Yeah, I'm going to Luke, I'm going to take that and just add my last sentence on it, if I may. One thing that really, really changed in life is this. We never talk to each other in a way that we can at least see each other and see the emotions. I mean, Vuk and I are very, very good friends. We used to see each other twice a year. And maybe between those, we chat on WhatsApp. Now, lots of times, we actually do exactly this. And, you know, the other day we said, well, let's drink wine together some evening, because I do it with other friends. So for all of you who are very fast running, take that into account, because that's very, very different than our usual life. So you think that, well, I'm locked down, I'm not traveling, I'm not seeing my friends. I'm seeing friends that I haven't seen for 20 years just by doing that now, because I can, because now became part of my life. So I would say all of you, should listen to what Vuk said and really think of how to do these things, because as soon as you get into life, the real life, you will never have it again.
Well, thank you, Samir. Thank you for these very thoughtful words and for the thoughtful words throughout this session. This is going to bring our conversation to a close for now. Thank you so much. This has been really fascinating. Tomorrow, we are continuing this discussion. And are you okay, Samir?
I am.
Have you tested yourself recently?
I'm vaccinated.
You're good. Well, then it's great. So tomorrow there's going to be, I think, an equally interesting conversation with another good friend of mine, and as a matter of fact, another good friend of Samir as well. It's going to be John Rendon, also from Washington. But it's going to be slightly a different tilt to the conversation. It's going to be much more about geopolitics and the United States politics and the military and what can be expected out of US-China confrontation sort of things. So another part of our gang, Samir and I are good friends with John, and we used to be seeing each other 2 to 3 times a year until now, but now we're seeing each other much more often electronically. And tomorrow there's going to be an electronic rendezvous with John. I promise this conversation to be as interesting and inspiring as this one with Samir. Now, thank you once again. Thank you to all of you. My last words go to Samir. Samir, it was amazing as always. Thank you, my brother.
Thank you all. And it was a really pleasure seeing you and seeing you all. You are wonderful, wonderful people, and good luck.
Thank you. All the best. See you tomorrow, guys.